All right, I thought we would just work through problem 10 from chapter 10. It's a long problem, and I'll add in a little wrinkle at the end. Um, so this problem asks, it's about a local golf course whose hired gun econometrician, I think that's a put down, has determined that there are two types of golfers, frequent and infrequent. So let's work through this. And let's see. The frequent golfers, so just label them over here. The frequent golfers have a demand for rounds, which is this, Q. F is 24 minus 0.3 P. And the infrequent golfers have a demand which is QI for infrequent is 10 minus 0.1 P. And the first question is if the golf course could tell the other thing is that marginal cost is constant, so it's equal to average cost, which is 20. If the golf course could tell a frequent from an infrequent golfer, what price would it charge each type? And so this is asking about third-degree price discrimination. So if the firm just simply, or the golf course simply just maximized profit independently in the two segments, how much would it charge, and how many times would each type golf? So we'll just solve the profit maximization problem independently in the two sectors. So first thing we need to do is to transform this into a demand curve, or an inverse demand curve. So price is 80 minus 3.33 Q is the inverse demand here. That means marginal revenue is 80 minus 6.66 Q. And to solve the profit, excuse me, to solve the profit maximization problem, we set marginal revenue equal to marginal cost. So we say 20 is equal to 80 minus 6.66 Q. That means 6.66 Q equals 60. Q then is equal to 9. And if we take 9 and put it back into the demand function, the quantity, or we'll put it back into the inverse demand, so 9 times 3.33, take that minus 80, we'll get that the price, the profit maximizing price for the frequent golfers would be $50. We can do the same thing over here. The inverse demand is going to be 100 minus 10Q. So marginal revenue is 100 minus 20Q. We'll set 20 equal to 100 minus 20Q. Marginal cost equals marginal revenue. So 20Q equals 80. That makes Q equal to 4. We'll stick 4 back in here, and we get 100 minus 40 is a price of 60. So for part A, the answer is that they would set a price of $50 for the frequent golfers. They'd expect 9 rounds each, and 60 for the infrequent golfers, and sell 4 rounds. Then the question goes through a discussion of second-degree price discrimination to make the different golfers self-select into the most profitable pricing scheme. I'm sorry, the greens manager has difficulty now telling frequent from infrequent golfers, and that's why we need to do second-degree price discrimination. If you can tell who's who when they walk in, you just charge them the appropriate price. But since you can't tell, in part B, we ask, what price should the golf course set for individual rounds of golf? And and so the answer is that the price is going to be $60. Okay, they're going to set the highest price for everybody. And part C asks, what would the discounted price be? If the chorus wished to maximize profit, what price and minimum quantity should it establish for the discounted plan? So the rule is that the price is $60, but you can get a discount if you play enough. And so the price would be $50 if quantity is greater than or equal to 9. Okay, so you pay $60 normally. If you buy more than nine or more, you could get a $50 price. Which plan will generate the greatest consumer surplus for frequent golfers? The individual all-around plan or the discount plan? So let's draw a picture of this. So for the frequent golfers, here's what we have. We have demand that has an intercept of 80. And what we're going to do for the frequent golfers is, well, we're going to offer them a price of either $60 or $50. What we've figured out here is that if we offer a price of $50, the quantity demanded will be 9. If we charge them $60, what will their quantity demanded be? Well, we put $60 into the demand curve, and we get 24 minus 18 is 6. And so the consumer surplus at a price of $60 is going to be 20 times 6 times a half. 20 times 3 is 60. The consumer surplus at $50 would be 30 times 9 times a half. So that's 135. Okay. Part E asks, which generates the greatest consumer surplus for infrequent golfers? So for frequent golfers, they're better off with the discount plan. But yeah, the lower price. And for the infrequent golfers, they have demand with an intercept of 100, and it's a steeper demand curve. The slope is minus 10. And again, they can pay a price of either $60 or $50. If they choose the $60 price, what we learned up here is that they will purchase 4 units at a price of $50. So if we put price of $50, 10 minus 5 is going to be 5 is the number that they would demand at 50. But in order to get the $50 price, we're going to force them to purchase at least 9 units. And so we'll come out here to 9. And what we've got is this. We have the consumer surplus at $60 is 40 times 4, 160 times a half is 80. The consumer surplus at $50 is this area here. So that area is 50 times 5, 250. Half of that is 125. But we need to subtract off this negative consumer surplus that we're forcing them to deal with by buying the extra units, getting out to 9 units in order to qualify for the $50 discount. And so that's going to be, let's see, we need to figure out what that height is. And so when the quantity equals 9, 100 minus 90 is a price of 10. And so this area is 40 times 4, 160, times a half is 80. And that means that the consumer surplus at the discount is 45. Part F asks, based on your answers to D and E, so this is D, and this is E, will the plan be successful in making golfers self-select into the most profitable plan for the golf course? Well, the answer is yes. The frequent golfers are better off with the discount plan, and that's what they'll choose. The infrequent golfers are better off with the higher price, and so that's what they'll choose. And so this is a successful plan because it gets each group to select a different price. If both of them selected the same price, if these golfers were also better off at the discount price, then there's no price discrimination. Everybody's paying the same price. But in this case, the pricing plan does work. And so it's successful. Part G asks, suppose each golfer came to the course with the word frequent or infrequent tattooed on his or her forehead. Is this information of any value to the golf course owner? Well, if the golf course owner knew that, they would do this. They would do the third-degree price discrimination. But not knowing that, if they use second-degree price discrimination, they come out in the same spot. Okay, they come out with exactly the same pricing and quantity, and so that information is really not that useful. All right. So one thing that's worth doing here is figuring out how much profit. This is my little twist on this problem to make it a little bit more interesting, perhaps only to me. We could figure out how much profit does the firm earn in this case, and how much profit would they use if they just used standard monopoly pricing. So the firm's profit in this case, so the profit is going to be total revenue minus total cost. The total revenue would be the revenue from frequent golfers, which is going to be 9 units times 50. So that's 450 plus, for infrequent golfers, 240, minus total cost is going to be 20. That's the average cost per unit, times the total number of units. So they're selling 9 plus 4, which is 13 units. And so that's 690 minus 20 times 13 is 260. And so the firm's total profit would be $430 under this pricing plan. Let's figure out what the firm's total, little technical difficulty there, folks. Sorry about that. So the firm's total profit under either third or second degree price discrimination is $430. Now let's figure out what the firm's total profit under monopoly pricing would be. So what do we know? We know that the for the frequent golfers, the demand is 24 minus 0.3 P, and the inverse demand therefore is 80 minus 3.33 Q. And for the infrequent golfers, the demand is 10 minus 0.1 P, and the inverse demand then is 100 minus 10 P. And we know that marginal cost is always 20. So if we draw a picture of this problem, what we need is to find the market demand. If we're going to use standard monopoly pricing, we need to have a single demand curve and set a single price for everybody. So our demand curves look like this. One has an intercept of 100 with a slope of -10. That's the infrequent golfers. And one has an intercept of 80 with a slope of -3 1/3. That's the frequent golfers. And so we can see that the market demand is going to have a kink in it at $80. Okay, so what we know is this. For price greater than $80, we can even say greater than or equal to $80. The demand is 10 minus 0.1 P. So the inverse demand is 100 minus 10 Q. And I'm going to grab my straight edge here, and so there's $80 right there. And my market demand then is this part of that first demand curve, for the infrequent golfers. And now what I need to do is to find the demand for price less than $80. Oops, for price less than or equal to $80. It's going to be the sum of these two demand curves. So the demand is going to be that plus that, which is 34 minus 0.4 P. That's an inverse demand of 85 minus 2.5 Q. Okay. And so the market demand then is going to be, it's going to be flatter than that, and so it's going to be something like that. So that's the market's demand. Okay. This up here, and then this down here. All right, so this for the monopolist then is the demand curve. The marginal revenue is going to be, it's going to have the same intercept, but twice as steep there, right? And then there. And so that's the marginal revenue. It has two segments, and there's a little kink in that at $80. And what the firm wants to do then is to set marginal cost and marginal revenue equal. we can see for sure that since marginal cost is always 20, we're going to be on this part of the demand curve and this part of the marginal revenue. So I don't really need to worry too much about this top section. And so what we can do then is just to set marginal cost equal to marginal revenue. So if price is 85 minus 2.5 Q, that's this part of the demand curve, then marginal revenue, this thing, is 85, is 85 minus 5Q. So we'll set marginal cost equal to marginal revenue. 85 minus 5Q equals 20. So 5Q equals 65. That makes the quantity 13. We substitute 13 back in to our inverse demand curve, 13 times 2.5, and take that result minus away from 85, we get a price of $52.50. So that's the market or the monopoly quantity and the monopoly price, just using monopoly pricing, right? What we're doing here is we're coming down to marginal cost of $20, and we're just setting marginal cost equal to marginal revenue. That's 13.5250. This firm's total revenue is going to be 13 times 5250, which is 682.50. Its total cost is going to be 13 times 20, which is 260. And that means that the firm's profit is going to be 422.50. And that's less than the $430 we found using price discrimination. And so we demonstrate here that the firm is in fact going to be more profitable if it uses price discrimination, either second or third degree, depending on whether it can identify its customers or not, versus no price discrimination, just standard monopoly pricing. All right, that's it. If I can get out of here, I will. There we go.